Reviewing, number one, rays parallel to the axis of the lens refract to go through the focal point. So I can show that by having a straight line from this glowing candle flame. It starts off parallel to the axis, and then it's going to, well, that's not a good one. Let's try that again. It's going to refract through the focal point like that. That's pretty good. Number two, rays that go through the focal point refract to go parallel. And let's draw a picture of that. So it goes through the focal point like that, hits the mirror, or lens, I should say, and then it refracts to go parallel, like that. Once we have drawn those rays, we can scribble out the incoming rays because they can sometimes just get things confused. But not too bad in this case because our image location is way over here. Here's the image of our candle. It's going to be upside down. It is magnified. It is real. Okay, label the image in 3 descriptions. As I just said, let's write these down. Oh, let's get it bigger than that. It is a real image because the light rays really truly are passing through that spot. It is inverted, which is a fancy word for upside down. And it is magnified. Number 4, label object distance, image distance, and focal length. Okay, object distance is over here. That is the object distance. Then the image distance. That's going to be DI. Remember, object distance is DO. And then the focal length. The focal length is the distance from the focal point to the lens. It's the same on the other side as well. Now, a lens could be made in a factory where you have different focal lengths on either side, but for our class, and actually for all of my college classes as well, we always had the same focal length on both sides. Okay. Practice. On the diagram above, the distance between the candle and the lens is 4. Between the candle and the lens, 4. The distance between the image and the lens should be 8. Use the Fedoti equation to find the focal length. Okay, so let's work this out, and then you folks will work out the last problem, which is just like it. You'll work it out on your own. So 1 over F is equal to 1 over DO plus 1 over DI. That is the Fedoti equation. And we put in our numbers then. One over F stays a letter because that's what we're looking for. The object distance we said was 4. Let's make this bigger. And then the image distance was 8. Turn the fractions into decimals to make the adding really easy. The 1 over f stays the same. The 1/4 turns into 0.25, and the 1/8 turns into 1.2. Add those together and you get 0.37. Now that is not our answer, remember? That is equal to 1 over f. We want plain old f. So we got to flip everything upside down. Let's write the word flip here because I've run out of room. I can't show it, but I can at least describe it. And then I take my fancy dancy calculator and I divide 1 divided by 0.37, and I get 2.7 as my final answer. 2.7. Any questions on problem number 5? All right, would you please go on and do number 6 on your own right now, and I'll ask people for step-by-step directions. Try number 6 on your own right now. Okay, Bianca, what number do I put, or where do I, the F is what we're looking for. Bianca, what number do I put in for the DO here at the bottom of the fraction? Bianca, what number do I put in for DO?
27.
27, thank you. And the 21, does that go on the top or the bottom of the fraction, Blake?
Bottom.
Thank you. Silly question, but just getting participation here going a little bit. Let's see here. When I change the 1 over 27 into a fraction, what does it become? What is the decimal for 1 over 27? Moving on to Brian.
Can you repeat the question again?
Sure, no problem. When I change 1 over 27 to a decimal, what does it become?
All right, give me a sec. Let me go take out my calculator.
Sure.
I got 0.037.
Yep, that's right. And the 1 over 21, Eric, what does that become? How about Gianna? How about Jonathan?
I got 0.476.
Yep. I'm going to add a 0 in there for you. Okay, so we add those two together and we get 0.0, let's see here, 84. And that is, remember, equal to 1 over my answer. So I got to flip everything over. Flip. And let's see here. I forget what the answer is. 1 divided by 0.084, 11.9. That looks familiar to me. 11.9. Give yourself a pat on the back if you got that. Ask a question in the chat if you did not get it and you'd like to know what happened. Okay, no chats. So let's look at the lens lab. What we're going to be doing is we're going to be, let's see here. Let me try to get this set up right here. I have 2 rulers. I'm going to put them at the 0 mark. So the 0 is right there for both of them. And I'm going to tape that down so that they don't wiggle and woggle. Oh, yep. Okay, and then I'm going to put a lump of clay right there, and I'm going to have my lenses. Remember, there are 3 lenses here. I'm going to put them right there. Okay, so at the 0 mark, we have the lens. We have 0 through 27 going this way, and 0 through 27 going that way, for 27 centimeters, that is. And then I'm going to get a glowing object known as a candle, and I'm going to put it way down here at the 27 centimeter mark, right there. Let's see if you can see that. Let me try to get my camera in the right place. Okay, yeah, that's pretty good. That's pretty good. Okay, so we have the lens here at the 0 mark of both rulers, and it goes 0, 1, 2, 3, 4, 5, all the way up to 27. And now over here, we have the 0 mark on the red ruler going up to 27 centimeters. And I'm going to be putting a little screen here to focus the image on. I can move that back and forth. Okay, so we're first going to shine the light from the candle through the big lens here. This is originally at 27 centimeters. That's the image, the object distance, object. And I can then focus the image over here. Now, it's kind of dim, so let me turn off the lights to see if I can show it any better. Okay, and there, I hope on the card you can see it. And, oh. I'm going to try one more step. I'm going to try to shut the shades of the windows and see if that helps. Okay, and the answer is no, not really. It doesn't help out too much, but hey, it was worth the try. Okay, now I can see the blur of the flame image right now. It's very fuzzy, and it gets a little bit sharper, 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 and then it gets fuzzy again, fuzzy, 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 fuzzy. And so what I'm going to do is there's a little range in here where it all seems equally sharp to me. So I'm going to first read where it starts getting fuzzy. And now I can't read, it's so dark in here. Hang on a second, isn't that silly? Okay, that's at the 21 mark where I can say, yes, that's definitely a little bit fuzzy. Anything closer though is pretty sharp. And then I keep on moving and up there it's kind of fuzzy. And that's at the 16 mark. So halfway is going to be the perfect thing, most likely. Halfway between 16 and 21. So let's see, that's going to be, let's call it 18. Okay, so the distance from the big lens to the image is 18 centimeters. Please write that in the chart below at the bottom or on another sheet of paper if you don't have your computer document going. 18 is the image distance. The object distance over here to the glowing object on the glowing candle is 27. So let me write that down here. 27, the image distance is 18. So to find the focal length, we're going to do the exact same thing that we did in the warm-up problems. 1 over f equals 1 over 27 plus 1 over 18. You're going to solve that right now for the f. Go ahead, go ahead, go ahead. I will wait for you. Okay, I'm now going to move this to 13. That's going to be a very short candle. And I'm going to shine it through the medium lens now, the medium lens. And I move this back and forth. And it's going to be, oh, let's see here. It's fuzzy at 4 and it's fuzzy at 6. So we're going to say 5 is the perfect focus. 5 centimeters. Go ahead and work out the focal length at this time. And lastly, whoops, we're having the object, the glowing candle, at the same location, 13. But I'm now looking through the teeny tiny lens. And it is definitely out of focus at 4. Gets better and better, and then it's out of focus again at 2. So between 2 and 4, so that must be 3. At 3 centimeters, it's in sharp focus. Three. So go ahead and do the Fedoti equation in the exact same way with the 13 and 3 in the appropriate locations.